if we have a continuous function that's differentiable, then the area under the rate function gives us the accumulation of change of that function over the interval from a to x. And this is represented by a definite integral. So in other words, f is the antiderivative of its derivative. So now if we replace the derivative with the function, then this here is the antiderivative of the function, and therefore this expression can be written as follows. And if we replace x in the integral with a dummy variable, we won't alter the result, because after you evaluate the integral, you'd substitute x for t. And now if we differentiate both sides, well, on the left hand side, the derivative of the antiderivative is the original function, and that's equal to the expression on the right hand side. So this tells us that the derivative of the integral, or antiderivative of the function, is equal to the original function. And that's the fundamental theorem of calculus applied to accumulation functions.